I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll understand how do we provide exponential equation from the given data. We'll also understand how do we figure out that the data really represents an exponential function. Well, in case you want to learn from me, you can always send an email on the address given. So let's look into the question here, which says, determine the equation that models the value of computer after n years of purchase. So after 2 years, the value is 960, after 3 years, 768, after 4, 614, after 5 years, 492, and after 6 years, it is 393. You can always pause the video, answer the question, and then look into my suggestions. Now, whenever we are given the data, the best way to go about is to find the first difference. So let's first find the first difference. That gives us a clue. If first difference is constant, it's linear. If second difference is constant, it's quadratic. But if first difference gives you ratios as constant, then it is exponential. So let's do 768 minus 960, right? So we are doing 768 minus 960 to find the difference. Then we will do 614 minus 768 and 492 minus 614. 393 minus 492. So let's use the calculator, find the answers. 768 minus 960 gives me a value of minus 192. 614 minus 768 gives me negative 154. 492 take away 614, and that is 122 negative. And we have 393 take away 492, that is minus 99. Since the first difference is not constant, it's not linear, and we see that there is a lot of difference between. The second will also not be constant, right? So now let's find out the ratios of all these. So let's calculate the ratio. Ratio means we'll do minus 154 over minus 192, right? And then calculate this value, ratio of these two. And then the ratio here will mean minus 122 over minus 154, and then this ratio, which is minus 99 over minus 122. So let's calculate these ratios now. So minus minus will cancel, so we have 154 divided by 192, and that gives you 77 over 96. Well, let's check the decimal equivalent of this value, which is equal to 0.80. The next one here is 122 divided by 154, and that is 61 over 77. Let's check the decimal value, which is equal to 0.79. The last one is 99 divided by 122. And that gives you a value of 99 over 122, the same value, divided, so decimal equivalent is 0.81. Well, as you can see, it is very close to 0.8, right? So we can treat this as all equal to approximately 0.8, right? Because the decimals are involved in rounding, this is a very, very good, very close. So we could actually approximate this to an exponential function where there is a decay by a factor of 0.8, right? So clearly we have a decay by factor of 0.8, correct? So with this information, can you now write down the exponential function which will represent the data? Perfect. You can now pause the video or write down the answer. Well, that is also tricky. We know the decay rate is 0.8. We know that when the number of years was 2, it was 960, 3, 768. How do we get the value of the computer as a general expression which could represent the depreciated value of this computer, right? So let's say to model the value of the computer, let's say this value of the computer is C in dollars after n years. Then C after n years can be written as, we're given 960, right? 960. We found that the factor by which it decays every year is 0.8, right? And after n years, we know after 2 years it was 960, and therefore the exponent should be n minus 2. Makes sense? That is critical because we were given the rate after 2 years. So that becomes the solution of this particular question. Makes sense? And this is how you should be doing it. Now here is another example for you to try. So we have given you a set of data here which is representing x and y values. The x values being 3, 4, 5, 6, y values being 80, 100, 125, 156.25. You can take this as a practice test question to write down the exponential function representing the information. Perfect. So I hope with this you get a good idea of how do we write exponential model for the given data. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.